So last class I have finished how to make isometric drawing by means of boxing methods, and some of the few examples I have covered. So just before I proceed further, just to take it a slight repetitions how to make isometric drawing. You will be given either 3 views or 2 views. That means top view, front view, or top view, front view and side view. This is a typical example where only top view and front view has been given. So first you number your points, number the points. Second, locate the axis with respect to width, h is your height, d is equal to depth. If I take it, this is my width, this is width, this is height and this is your depth. Then locate each point and connect the points. Now if you visualize this example, particularly the top view as well as front view has been given, no other view, side view is not given. So there is a notch here, and now it seems to me, because as not side view has been not been given, it is throughout in the depth directions. This is your first understanding, it is throughout in your depth directions. If you locate these points in your isometric box, then if you know the distance, then very easily you can locate in the depth directions where these points are lying. Let us see it. First step is your identify axis, where you start your 0, 0. In this case, axis is not necessarily the point here in your any of the view, it may be anywhere else. You can take a coordinate anywhere else. Once again I am repeating, you can take anywhere else. So for this example, we have considered axis at here, it is your 0, 0. Then accordingly mark your 0, 0, mark your width, this is your width, then same width has been marked in your isometric box in that directions. Then height has been marked in that directions. Then similarly depth has been marked in that directions. Once you get the dimensions, width, height and depth, then finish your isometric box. This is what you are finishing your isometric box. Then mark each point, mark the points. Once you finish your isometric box, mark the points in the views. Then same points, what is the distance from the, suppose I mark this point how far from this axis or reference point with respect to width, height and depth. Once you locate these coordinates, then you can very easily mark these points. Let us start with one by one. I finish this box by means of darkened lines. Then start with these points. If you look at here, 1, 2, 3, 1, 2, 3, these are the points, and 1 prime, 2 prime and 3 prime in the depth directions. So first you locate 1, 2, 3. As I said, once you locate 1, 2, 3, if your depth dimension is known with respect to 1, 2, 3, then you plot in that depth directions, then you can locate 1 prime, 2 prime and 3 prime. So first start with the point 1. What is its width? Point 1 is your 0.75. If you look at here, this point 1 is located 0.75, this is your width, and 2.0, this is your height. If I write it, this is my width, this is height and this is depth. So this is 0.75 and height is 2.0 for point 1 and depth is what? Depth is 0 because you are starting from here. With reference to this coordinate, this reference point, depth will be towards this. So depth is 0. Then you start with 0.75 here in isometric box, then 2.0 in your height directions, locate your point 1. So this is your point 1 what you have taken the reading. Then similarly start with point 2. Point 2 is what? If I take the point 2, 1.5, this distance from here to here, width again 1.5, height 1.25 and depth is equal to 0. Depth 0 means 1, 2, 3 is the front face. Depth wise it will continue. So it is 1.5, 1.25 and 0. Now taking into 1.5, 1.25 and 0, mark these points of 2. This is your 1.5, then this is your 1.25. Then you locate this point 2. Coordinates of this point 2 has been located in isometric box. Similarly point 3. Point 3 marks 2.25, 2 and 0. 2.25 is from here to here distance is your, here to here distance is your 2.25. Here to here distance is your 2.25. This is in width direction because this is my axis 0, 0, 0. And from here to here with respect to here, this is your 2.0. Mark this point 2.25 and 2.0. Finish your point number 3. So you locate 1, 2, then point 3. This is your point 3. So 1, 2, 3 has been, once it has been located. Now next question is, where is your 1 prime, 2 prime and 3 prime? If you looked at here in the figure, in the top view, 1 prime, 2 prime and 3 prime, they are located in depth directions and it is in the equal distance. It is in equal distance. It is nowhere else like here or here or here. It is here, it is here, it is here. So distance from here to here, here to here, here to here, this is your equal distance in depth directions. So now it is very easy to locate. From point 1, take parallel lines in depth directions and measure what is the distance of the depth. And then if I take in the depth direction like this distance is known because this distance is known. This is known, this is known. I can very easily locate 1 prime. Similarly, I can locate 2 prime. Similarly, I can locate 3 prime. This is the procedure has been followed. Let us see. Yeah, this is a depth direction, this is a complete depth. So this is your 1 prime. Similarly, this is your 2 prime, depth direction, this distance same. Similarly, 3 prime, depth directions. So now you have located 1 prime, 2 prime and 3 prime. This is the critical face or critical surface of this, particularly this drawing, because there is a notch, it is continuing throughout. So now once you finished, then finish your drawing. Darken appropriate lines, means entire drawing it has to be darkened so that the proper shape should be visible as well as readable. Then draw it, draw it, draw it. Now once it is over, if I remove it everything, how it looks? I hope it is clear to all of you. So this is what once you locate. Now this is your isometric plane, this is your isometric line, but this is non-isometric lines as well as this is your, this plane is your non-isometric planes. So non-isometric planes on principle you cannot draw lines, only you can locate these points on isometric planes, then join the lines, join the lines. So this completes. Up to this we have covered last class. Thought to repeat it so that in further example it will be helpful. This part also I have completed last class, how to do a circle. So this part also I have shown making isometrics. This is interesting without locating the points. Once you start practicing locating the point one by one, then you have a visualizations how the isometric drawing has been drawn. So this is the view has been given, top view, front view as well as side view has been given. So isometric box has been prepared. Then with respect to isometric box, so front view I plot it in the front, top view I draw it in top, side view I draw it in the side. So if I am taking it this way, you can look at these animations, how interesting it is. Take it one by one. First I draw the side view as it is, nothing doing anything else. This is a side view. Whatever you are seeing here, this is your side view. Then draw your front view as it is. Draw the front view as it is. Now it is your front view. Similarly, draw your top view. Draw your top view. This is what you have done. Now, then what I am doing, you looked at it. Imaginations how this isometric view will come into picture one by one. Merge it, taken it back one by one person, then again taken it back, then again taken it back, then taken it back here, then taken it back here, then draw it without doing any point system, marking the points in the isometric box. With a simple practice it can be done with imaginations. So now how do you check? This is what you have drawn. How do you check that whatever you have drawn it is correct? Now you can cross check with your isometric drawings. With respect to your views, there are three views: top, front and side view. So your front view looking this object from this side. So from this side you looked at whether your front view is coming same or not. If I am looking at from this side, what will happen? This point and this point is going to merge, right? It is going to be merged completely. Now because there is a notch here, I can see here, I can see here. So this is what it is going to be merged. Again this slanted surface or inclined surface, this point and this point is going to be merged, right? Now this surface is an inclined surface. If I take it looked at from this side, what happened? This point and this point is going to be merged, this line particularly. Now it will be no more inclined in the front face. So that means this point will be going like this. So it will be only looking like this kind of shape. Now looked at whether this is the whatever is your isometric view. From there, if I am looking at the object from this side, from the front view, whether this is your front view or not, exactly it is matching your front view. Now similarly you can look at your side view. Side view, what happened? If I am looking at this is the thing, it is there, and there is a surface, inclined surface I can look at. What is this? This is your hidden line. So this hidden line of what? This hidden line, because there is a notch here inside, it is going inside. So that means this line I cannot see it, rather it is a hidden line. Similarly top view, it is exactly matching. That means my isometric drawing is correct, because I have drawn this isometric drawing based on the views has been given, top view, front view as well as side views. Circles appear as ellipse when drawn in an isometric sketch, remember. Now isometric circles looked at here. Center of any circle tangent to a straight line lies on a perpendicular from the point of tangency, that is true. Four center methods of drawing isometric circles ellipse may be used. If you remember, we will go back to my second class. Curves and ellipse, basic things I have explained. There are two methods to draw your ellipse. One is your exact method, other is your approximate method. One of the approximate method is your 4-center method. So in this case, 4-center method you can always use so that draw your ellipse. Box method can also be used for drawing isometric circles or ellipses. Let us look at here curves in isometric. Circle or any other curves will not show in its true shape when drawn in isometric. Definitely, because you are looking at 45 degree with rotation with respect to vertical axis as well as 20 to 30 degree rotation about your profile axis. So it is not necessarily that you are supposed to see true shape. So circle will be seen as ellipse. Any curve can be drawn by plotting points on it from isometric reference line. Remember, the way I explained, from the top view or side view or front view, mark the points, any curve, mark number of points 1, 2, 3, 4, 5, then it can be projected back, or it can be based on their coordinate, you can project it on isometric box, then it can be drawn very easily. Frontal plane, orthographic, this is your front view, there is a circle. Now frontal plane in isometric, so it will not be no more a circle, it will be an ellipse. Looked at here, how the ellipse has come into picture. Similarly, profile plane, this is how it looks. So in profile plane, how you are going to draw your ellipse. Similarly, horizontal plane or top view, how you are going to do it. So depending on sketch plane, this is your top horizontal plane, frontal plane, this is your front, profile plane, this is your profile plane. Isometric view of a cylinder, looked at here, orthographic views, this is your front, this is your top of a cylinder. So a circular feature in the orthographic view will appear elliptical in the isometric view, because you cannot see as a true shape. Let me start with this. Draw the isometric box, draw it, then mark your 4-center, then by means of 4-center method, this method I have already explained in the second class. You can go and brush up with your how to draw ellipse by means of 4-center method. It was well explained in the second class. Then find it out your 4-center, then draw your ellipse by means of your approximate methods. This is your ellipse. How the circle in the orthographic view, how it looks in isometric view, this is your ellipse. Then once you get the front surface of the ellipse, then you can continue back side in the depth directions, there is no problem. So either you can take it, there are two ways, either you can take it point by point, take the points, right? In depth direction this distance is fixed, from there you can draw the parallel lines, and where these points are marked, you mark it. Then taking the points, you draw an arc here, taking this as tangent and this as tangent, this can be done. Then similarly you can take this side, one quarter you can take it, this quarter, this quarter, this quarter, this quarter. 4 arcs are required. This way it has been drawn. Or you can do it in the depth direction, again you take it, draw it by means of 4-center method. Draw it by means of 4-center method. Then you finish it up, then join it surface to surface, you join it, then it has been joined. Then you take it out, back side, how it looks, this is your surface. This is your cylindrical face, a cylinder, and remove, this is your main cylinder, and these are all your construction lines. This will be drawn in lighter side. So this finishes. Drawing thin object with thorough hole. Looked at here. This is a very thin object. There is a hole throughout in the depth directions. If I am taking, this is the width, this is the width, this is the height, this is my depth. This is my depth. Now determine appropriate plane. First you determine which plane you are going to draw it. Once you have determined, first step is determine the appropriate plane. Then once you have determined in this plane this hole is throughout, then locate center of the hole, where it lies, center of the hole, because obviously once this is your object, you can very easily find it out where is your center of the hole from here. Then you can locate your center of your hole. Then determine radius. From this you can take the measurement of your radius, determine the radius. With respect to the radius, you can prepare 4 quadrants, or maybe a parallelogram can be drawn. And once determine the radius, then create the ellipse by means of exact methods or by means of approximate methods. Once this ellipse has been created in one plane, then depth directions throughout it can be very easily created. So this is a step, repeating, determine your appropriate plane and locate center of the hole, determine radius, and then create ellipse on that plane. Create ellipse on that plane. If you looked at here, this hole is throughout. That means you are creating ellipse only in the frontal plane. That means in depth direction also you have to create it. Next step, determine the depth. What is the dimension of the depth you determine? Then accordingly this depth has to be projected back. 1, 2, 3, 4 it has to be projected back. Then box radius, you have to find it out your box radius. Then locate center. Backside also box radius you find it out the plane. Then backside also you locate the center, where the center lies, because this center to this center is going to match, because this is your center of line. Then locate center of lines. Once you locate the center of lines, then sketch the ellipse in the back side or rear side. Once you sketch the ellipse, looked at here, this ellipse has been created in the front plane or frontal plane. This ellipse has been created in the rear or back face. Then once you draw the ellipse, then looked at the feature, go to the first slide, how it looks. One ellipse, other ellipse is half, because this is slightly inclined. That means this is your isometric views. So inside not necessarily you can see it altogether. So if I go it in this way, so I draw this with a thick line, this is my first ellipse, then second ellipse which is inside this ellipse, that has been drawn, and rest part, this part you can remove it. So and darken it. Once darken object lines and erase construction lines, these are all your construction lines. So at the end you have to draw the construction lines by lighter, or maybe you can erase the construction lines. So then you darken the entire object, this and this. So this finish what drawing thin object with a hole throughout. If you looked at here, initially it looks like, later on we have drawn this way. This is what drawing thin object with a hole throughout. Drawing arcs in isometric views. How these isometric views look at the object? This is your object, isometric view. One of the edge there is an arc. This is the edge where there is an arc. Right? How you are going to do? Draw your regular isometric box. This is your regular isometric box. Then determine appropriate plane, because top plane, bottom, then this is your depth direction, determine appropriate plane. This is your appropriate plane. Then locate center of the arc. If you looked at here, this is my radius. So you locate where is your center of the arc is there. Then once you locate the center of the arc, determine the radius. What is the radius? Taking consideration of this radius, you finish it up. Then create an ellipse. Create an ellipse only one side, because if you look at this feature, one side it is arc. Then here creating an ellipse one side, then determine the depth. You determine this is your depth directions. Then similarly locate center line and box radius for the bottom part. Top part also you locate center line and radius, bottom part also you locate it. Then sketch the entire ellipse of the bottom part. Drawn at the top part, ellipse for the top part, ellipse for the bottom part. At the bottom, this ellipse should be parallel to each other, remember, because if there is some dimension missing, then it will be unequal or uneven. Then once you have drawn it, then draw a common tangent to ellipse. Add tangent line, right? I added tangent line. Then erase all other parts. Once you add it, because we need to have this line, if you look at here, this to this, then in this figure we need this part completely, this construction line, it will be erased, or maybe slightly lighter side construction line, lighter pencils you can use. So this is your final, how it looks. I will stop it here. Dimensioning and other examples I will cover in the next class. Thank you.